fill in all of them. So right on page 11, yesterday we already filled in the top where it says divergent plate boundaries. This is what your quiz was literally just on, so this was not news to you. Divergent plate boundary is a location where two plates are moving away from each other. But I want to add a little bit to that and kind of have you think about what happens when these plates move away from each other. So we talked yesterday, what are the plates made out of? What part of the earth? It is bedrock, but what layer of the earth? The lithosphere, which is the crust and the rigid mantle. Good. The lithosphere and the plates are floating on what layer? The asthenosphere. That was one of the questions on the quiz, in fact. That was the first one. Did you guys know where to look to see what order those rock layers or those layers of the earth went in?
Yes.
Okay, right on page 10. So the lithosphere is floating on the asthenosphere. What's so special about the asthenosphere? It's gooey, yeah. So it's liquid-ish. So it's that partially melted layer. So it's got some lava going on it. So these plates, we got the lithosphere plates sitting on the ooey gooey layer. When they pull apart, when the lithosphere plates pull apart, what's left there? It's not just a hole, there's something under it. Lava, the asthenosphere. So when the lithosphere pulls apart, underneath the lithosphere that's now exposed because it pulled apart is the asthenosphere, that ooey gooey hot layer. So it's kind of shown here in this picture. So the plates are moving apart. Remember, this is all happening underwater for divergent plate boundaries. So the two plates pull apart, exposing hot magma, hot lava to the water. What happens to that lava when it hits the water? It cools almost immediately. And right here at this ridge, at the divergent plate boundary ridge, brand spanking new baby igneous rocks are formed right there. So ridges are the places where baby rocks are born. Any of you guys, I'm going to use some of your families, I think, as an example here. And please don't mind any sibling stereotypes that I'm about to do. Are there three of any of you guys, like you and your siblings? Have I had any of your siblings? I always like to do this one. So I'm going to go ahead. I know I have Phoenix's sister, so we'll go with that. Phoenix, is she the oldest? She is. So, and she's only a year older than you, right? Okay, so Phoenix has a sister, Amelia, right? How do you spell her name? Okay, that's what I thought. That's what I was gonna go with. So Amelia got to, and how many of you are the older sibling? Okay, you are going to understand what I'm about to say. You younger kids, especially if you're babies, none of you are gonna understand. Now, let me just say, as an oldest sibling, I know all of this is 100% true. As a parent, I will inform you that this doesn't happen in real life. Okay, but as an oldest sibling, this is exactly true. Okay, yeah. For this is just make believe. It's not real anyway. It's just I like to use it with things people can relate to. So you might be able to relate to this. Okay. So here's the deal. You oldest siblings, Amelia didn't get this too long. She's only a year older than Phoenix. You guys know how it is to be an only kid, right? Some of you remember the good old days before your brother or sister showed up. Got to be the one and only. Okay. But here's the bad part. What happened when that baby came along, the next kid? How stereotypically did you feel as the oldest kid when a new sibling showed up? Angry. You went from being perfect to the one and only, everyone's only had to buy one set of Christmas presents. And then this little brat, my brother, showed up. 6 years I got to be an only child. And the jerk showed up and kicked me right out. He literally took my bedroom. Okay, he took the room right next to my parents. I had to move down the hall. Okay, any of you relate to this?
Yeah.
Okay, that's besides the point, but I had to get kicked out of my room.
Yeah.
But if you get the
Oh.
building and it's a W.
Work with me. Didn't feel like it at 6. So same thing probably happened to Amelia. She got pushed down the hall.
No, I actually lost my room. Me and my brother.
No, we're not there. You couldn't have lost your room. You didn't have a room. You weren't alive yet.
No, I actually.
This
was
is
alive.
when your brother showed up though, right?
No, okay, so I have a stepbrother.
Oh.
Me and him shared rooms. And then he went off to college and then I had to get the small room and Amelia got the bigger room.
That, well, I mean,
That's not fair.
but are you focusing on what I'm saying? This is when you were born. It's
fair.
not now. It's not yet last year. It's when you were born. And it's not all real. I am making it up, okay? But it just, you can relate.
Uh-uh.
So Amelia's living her dream, then Phoenix shows up. So Amelia has to vacate her room or her location at the ridge where baby rocks are born. So Amelia gets pushed to the side. And did I just butcher your name or did I spell it right?
Yeah, you saw that.
Cool, that's luck. So now Phoenix, he's the baby. He's living the dream, being the youngest kid, and he pushed Amelia to the side. Now, in real life, we only get pushed aside, us older kids, but in rock world here, not only do the older siblings get pushed to the side, they get split in half and pushed to the side. So not only is Amelia no longer occupying the prize spot, she's split in half and being pushed out in both directions. And Phoenix got to occupy this place in the middle of the ridge there. So he's the baby for a while. Did you get to be the baby for a little bit?
Yeah, for like 4 years.
Ooh, 4 years. This explains some of this. This is explaining some things I know about you. I'm just kidding. Okay, so Phoenix got to be the baby for 4 years, occupying the awesome location at the ridge. But then Phoenix, your brother came along?
Stepsister.
Oh, stepsister first. Oh, who's she? Gracie. So now Gracie's the baby?
Hudson actually is.
Oh, but no, I mean like after
Oh,
you.
yeah.
So now, where does Phoenix get pushed when Gracie came along? So Phoenix, what do you think? What's gonna happen to you? He splits apart. Gracie is living the dream on the ridge. Phoenix. Oh, now I'm butchering your name. Phoenix gets pushed apart and pushed to the side. Where the heck is Amelia in this whole situation?
Go out to the side.
She got pushed even farther out. And I hear you just said you got another one. So Gracie got to live the dream for a little bit, but then Hudson, you said? So Hudson is now officially the proud owner of the ridge. Gracie, what happened to her? Split in half and pushed to the side. Phoenix. Oh, getting pushed even further. I keep butchering this, but where the heck did Amelia have to move to in this situation?
She gone.
She's practically living in the garage in this scenario.
Well, where she lives. Yeah, actually.
So no, none of this was truthful. But I just wanted you to get the idea. At these mid-ocean ridges, it's just like you guys, when you were born and pushed away for your younger siblings. Again, it doesn't really happen, but it does happen for rocks. What I'm trying to show you here is that the youngest rocks in the ocean are found right here on the ridge. That's where baby rocks are born. Right at those divergent plate boundaries, which we also know are called ridges, the baby rocks are found there. What happens as we go away from that ridge in either direction? What happens to the ages of the rocks? They get older, just like Phoenix's siblings are here, and they're older as you go out. So what do you need to know about this? What if this was a multiple choice question? And there was locations labeled on this picture of a ridge. Here's one question. Don't shout anything out. I want everybody thinking about it. Which letter A, B, C, or D is the oldest? Okay, you weren't supposed to shout it out, but who agrees with Chris? Is it A? Okay, A is the oldest. Which one is the youngest? A, B, C, or D? Give everybody a chance to think. Phoenix, which one's the youngest? C, because it's closest to the ridge. And here's a third question they might ask. Which letters A, B, C, or D are approximately the same age? Remy, can you figure that one out? B and D, and how do you know that? They look about the same. I tried to make them the same. I could have got a ruler out to make sure. But B and D are about the same age because they're about the same distance from the ridge. So that's one thing you got to remember about divergent plate boundaries that we hadn't talked about yet. But then there's one more step to this. Uh-oh, you got this picture also in your packet right below that. Looks like a piece of bacon. It's not. It does. Yep. This is not the first time I've looked at this one. So this is still the same idea. We've got the ridge here, and the ridge is the baby rock. So Hudson is the baby. Gracie is one layer out. And then Phoenix is after or out farther than, oh, there's an E in there, Phone. E, that's what I meant. Yeah. Cornelia doesn't even make this picture. All right, so this is Phoenix's life again here. We've got the baby, then Gracie, then Phoenix. Now, you guys remember the mineral magnetite?
Yeah.
What was so fancy about the mineral magnetite? It's magnetic. Now, what do you guys remember about magnets from like elementary or middle school science?
North and South Pole.
They have a north and a south pole. That's what I was really looking for.
Right.
There's lots of other things that are also true, but that's what I want to focus on is they have a north and a south pole. Well, magnetite has a bunch of little magnets in it. And each one of those magnets inside a magnetite has a north and a south pole. One thing that you may or may not remember about magnets is if you suspend them, meaning you could hang them from the ceiling or float them in a liquid, the North Pole will always point north, the South Pole will always point south. That's actually how olden day compasses worked. They were nothing more than magnets that pointed north. So what you find is if you go to the mid-ocean ridge, which is currently being made, you find little pieces of magnetite that make complete sense. Those magnets, I'm just going to draw a little bar magnet here, have the North Pole pointing north and the South Pole pointing south, just like you would expect a magnet to find. They all line up normally. That's called normal polarity. But what scientists have discovered that if you go out one layer to these Gracie rocks, they're a little weird. Does that kind of fit, Phoenix? Gracie, a little weird? Yeah, I don't know, Gracie. Everybody's a little weird. And these, what scientists have discovered about these rocks that are slightly older is that the polarity has actually reversed itself. Meaning instead of north pointing north, south points to today's south. So they're reversed, they're backwards. And what scientists have concluded is, for some reason, the North Pole and the South Pole throughout history have actually reversed themselves. You don't need to understand how or why, because scientists don't quite understand the how or why yet, but they know it's happened. They see proof for it. They see that these have reversed themselves on the ocean floor. When they go out to the Phoenix rocks and they dig up those rocks, guess what they find there? With the polarities. They are more rocks, the same as what you think? Same as the original. These go back to normal polarity. What do you think if we added the Amelia rocks out here? These ones would be reversed again.
Flip-flops all the way.
Hmm?
Flip-flop.
It just keeps flip-flopping, and we have a couple minutes to get this in your notes, and then we'll be done. So it's called paleomagnetism. It's right there on the bottom of page 11. Not quite the bottom, middle left-hand side, right underneath the original picture we were looking at, paleomagnetism. Paleo means old, magnetism means magnets. This is alternating bands of igneous rock on the ocean floor show the Earth's magnetic field has been reversed in the past. It also shows the crust has shifted. What's up? This is what Alfred Wagner needed.
Yeah.
So this is what he needed. This was his how and why. Here was more precise evidence to say, look at this, the floor is moving. So we'll pick up here tomorrow. We just needed to tie in a few loose ends here. So get this in your notes, and then we will wrap up continental drift tomorrow and start talking about earthquakes tomorrow.
Well, science does that. Science is science. You figure one thing out and then you figure another thing out at the same time.
Yep, that's exactly how science works. I can put that back up, sorry.